Hello everyone, my name is Victor Brimer from M&B Renewable Energy. As you may know, we are into sales and installation of solar systems. I welcome you all back to this channel. In my introductory video, I said this training is all about design and installation of solar system, how to select the right equipment for your solar system installation that will not give your client any issue. So before then, we need to understand electrical basics. For you to design a working system, you need to understand electrical basics. So before this, we are going to be starting with main electrical parameters. Main electrical parameters. So we have three main electrical parameters. The first one is the current. The second one, the voltage. The third one, the resistance. So these are the three main electrical components. So we will be starting with current. What is current? Current is the flow of electric charge or the flow of charged particle from one point to another. The flow of charged particles from one point to another. So these particles can be positively or negatively charged, so it depends on the medium. We have negatively charged particles. So this can also be called the electrons. Then we have the positively charged particles. So in some of the medium, the major charge carriers are electrons. Then we have some that the major carriers are negatively and positively charged particles. Like the first one, let's say the conductor. The major charge carriers here are electrons. What does this mean? It means what constitutes current in a conductor are what? Are electrons. Like your copper cable, e.g. copper cable. So the flow of charged particles, the charged particles are what? Are electrons. So you should take note of this. At least this is what form the major carriers in most electrical circuits. Then we talk of another medium, semiconductor. So what constitutes current in semiconductors are electrons and holes. So that is the reason why I said some are negatively charged, while some are both negative charge and positive charge particles. So in the case of semiconductor, the major charge carriers are electrons and holes. So we use what example like your solar panels. So what constitutes current in your solar panels are what? Electrons and holes. You take note of this because solar panel is a perfect example of a semiconductive device. You know, they are made of what? Silicon. Then we have another medium, electrolyte. Example of electrolyte like your salt water. Then H2SO4. That is your hydrogen tetrasulfate 6 acid. So this is the type of electrolyte you find in your tubular battery. So the major charge carriers in electrolyte are negative ions and positive ions. You should take note of this. In the case of conductor, the major charge carriers are electrons. In the case of semiconductor, the major charge carriers are electrons and holes. In that of electrolyte, we have what? The negative and positive ions. So that is that. Now we talk of the SI unit of current. What is the SI unit of current? The SI unit of current is what? Ampere, which is A for short. SI unit means the International System of what? Units. So current is mentioned in what? Ampere. So we have other higher units, like if you multiply this by 1000, we will talk of kiloamps and the rest. So let's now discuss current with regards to our solar panels. In our solar panel, there's what we call the IMP, which is the current at maximum power. Our IMP is the current at maximum power. There's another one we call the ISC. This is what's called the short circuit current. You should take note of this and this. And if you are designing your equipment for your solar system setup, let's say your breakers, your surge arresters, your cables, you should mainly pay attention to this short circuit current. And what is even the short circuit current? You know, if your positive terminal and your negative terminal mistakenly touch each other, the current that flows is what we call short circuit current, ISC. The current is always higher than the current at maximum power. So if you check your solar panel, the nameplate, you will see that your short circuit current value is always higher than your maximum power current. That is the current at maximum power. So the reason why you have to design your cables with recourse to the short circuit current is that if mistakenly your positive cable and your negative cable touches each other, the current that will flow through the cable should be big enough to carry that current. So even your protectives, they should be able to act to isolate the current so that it doesn't get to your main component, your charge controllers or your inverters. And if you are even designing for your cable, you will have to add safety factor. If you don't design, you design 125%. That is about 1.25. So that is how important this very parameter is. You should pay attention to this. The short circuit the short circuit current. And there's another point I need you to note, that in your circuit, if I'm talking about circuit, I mean a complete path through which your electric current flow through. Like your solar system is a circuit, your house wiring, you understand. Any complete path through which current flow through is called electric circuit. If you are designing any system, you should take note of current that current is directly proportional to the cross-sectional area of your cable. You should take note of this. Current is directly proportional to the cross-sectional area of your cable. That means if you have a high amount of current that will flow through your circuit, you should be able to get a big size of cable that will be able to design and withstand this. Because if you get a cable with a very small cross-sectional area, what happens? The cable will heat up. So this is one of the causes of what? Electrical fire. If you want to get the right size of cable for the what? For the current. There are formula for all this, but we will get to that. So I just need us to understand this basis first. That is that now we move to the voltage. What is equal the voltage? We say voltage is an electrical force. Voltage is an electrical force that causes current to move from one point to another. That means if current moves from point A to point B, that electrical force that causes that motion is what is referred to as what? As voltage. So you can also call voltage the potential difference between 2 points. Potential difference. And you can also call it electromotive force. That's if you are dealing with cells. Electromotive force. This is PD. Why this is what? EMF. They all refer to as what? Voltage. So I told you about the potential difference between 2 points. You understand? That is what? That is voltage. And the SI unit of voltage is volt. SI unit of voltage is volt, which is V for short. Now we talk of your solar panel. In your solar panel, we also have two main voltage. One, the VMP, which is the voltage at maximum power. And we have the second one, the VOC, which is what? The open circuit voltage. So what is VMP? The voltage at what? At maximum power. So this is the voltage with which the wattage. This was what was used to calculate the wattage. And how can you get this? You can get this after you must have connected everything. So if your battery, for instance, if your battery is during a bulk charge of your battery, bulk charge, and at peak, within peak some hours, if you take your meter and you check the EPU terminal of your charge controller, the voltage you will be getting at this point is your voltage at what? Maximum power. That is during bulk charge within peak sun hour. So if you test, the voltage you'll be getting is your what? Is your voltage at maximum power. Then we talk about the open circuit voltage. If you take your solar panels, then you use your meter and connect and check the voltage you are getting. That is what we call what? Open circuit voltage, because the circuit is not yet what? Connected. We still have the positive terminal one way and the negative what? Terminal one way. That is what we call what? The open circuit voltage. And if you are designing a system, you need to pay attention to this open circuit voltage. There is a reason why I say you should pay attention to this. Let's say, for instance, you connect a solar system and the total VOC, or your net VOC, for instance, is, let's say, 150 volts. And you are using a low voltage charge controller. Let's say the maximum solar voltage of your low voltage charge controller is 145 volt. Of course, the VMP will be lower than this. So if you connect, let's say for instance, your VMP is also what? 145 volt, your net VMP. So if you use this to size your solar charge controller, this is what happens. Once the battery gets fully charged, once your battery gets fully charged, the current flow is 0. And at 0 current, the voltage you will be getting is what? Open circuit voltage. So once your battery is fully charged, so this is what will be coming into your charge controller. The 150 volt, of course, is higher than this. So definitely it will destroy your charge controller. So this is the reason why that if you are designing your equipment, you use VOC, the open circuit voltage. There is a reason why we have this, because this is the maximum voltage the panel can produce. The maximum voltage the panel can produce. So if you are designing anything, you design with reference to your what? To your VOC. It is very, very important. Thank you. That is it for that. And you should also take note that your voltage, if you are designing, the higher the voltage, the higher the insulation. Voltage is directly proportional to what? Insulation, the insulation of your cable. So you should make sure the cable you are using is well insulated. It is very, very important. So in the case of current, we say current is directly proportional to the cross-sectional area of your cable. Why the voltage is directly proportional to the insulations? Please be taking note of this point. We are going to be applying this when we get to the main solar system design class. Then we talk of the resistance. What is resistance? Which is the third one. Resistance. Resistance is the opposition to the flow of electric current. Opposition to the flow of electric current. So your circuit resistor opposes the flow of electric current. It limits the flow of what? Electric current. So that is that. And the SI unit of resistance is called ohms. And this is the symbol. The SI unit of resistance is called what? Ohm. Note, we only make mention of resistance if the circuit is pure resistive. If the circuit is a pure resistive what? Circuit. Yet if we are dealing with an AC circuit, in AC circuit, impedance replaces resistance. Impedance, because here we talk of what? Resistive circuit. Here we talk of inductive circuit. Here we talk of capacitive circuit. So we have resistors, inductors, capacitors. So the resistance offered by this, you understand, by resistor is what we call resistance. The resistance offered by inductor is what we call inductors. The resistance offered by capacitor is what we call capacitor. You know, in your AC circuit, we have all these, the capacitor, the inductors. They all offer their own what? A kind of a level of what? Resistance. So the sum of the resistance is what we call what? Impedance. So if we have been discussing AC circuit, impedance replaces what? A resistance. Now there is a law governing these three parameters. There is a law governing what? These three parameters, and that law is called what? Ohm's law. Ohm's law. And what does the law say? It says that voltage is directly proportional to current at constant resistance, which means if we break this in, your voltage will be what? Will be IR. At constant resistance, voltage is directly proportional to what? To current. Please, you need to take note of this formula. V is equal to IR, because you can manipulate it into whatever values you have to work with. V is equal to what? V is equal to IR. So that is that. So in our next class, we are going to be discussing power. We're going to be discussing the product of this and this. I've been seeing some questions online, people asking which electrical parameter charges battery. Some say it's current, some say voltage. You understand, the truth is none of this can do it alone. They have to come together. It is the product of this and this that charges your battery, which is power. It is the power that does the actual job in your electric circuit. It is the power that causes shock. It is the power that causes electrocution. It is the power that filled your electric iron, that is now converted into what? Electrical energy. It is the power that filled your electric motor, that is converted into mechanical energy. We are going to be discussing it in our next class. Please, anything we discuss here, you have to take note of all the important points. They are very, very important. Like the open circuit voltage, the short circuit current, the voltage at maximum power, the current at maximum power, the relationship between current and the cross-sectional area of your cable. And the current is directly proportional to the cross-sectional area of your cable. Then the voltage is directly proportional to the insulation. If you are working on a high voltage system, you have to be mindful of the insulation. The cable has to be insulated. Anything you are using has to be well insulated to avoid insulation breakdown after some years. Thank you. So with this, we bring today's class to an end. Please don't forget to like. So what you feel about this very class? What you feel about this? Drop it in the comment section. Please share, and above all, subscribe, so that whenever I drop subsequent videos, you will be notified. Thanks, and bye for now.